So I had a student reach out to me with some questions that they had in 11.4, and I wanted to just make a video to help this student and then also help the rest of the class. And so these are tied to very specific examples in 11.4, and I'll run through them again and see what we can do in order to help out as many people as possible. And so the first question that I'm going to address is like questions 7 and 8. They both were very similar. So this question says a fair die is rolled 5 times. A 2 is considered a success while all other outcomes are failures. Find the probability of 4 successes. And so this is supplementary to my other videos. And so let's go ahead and do this. So we would like the probability of 4 successes. So I have to say to myself, okay, what's a success? It's getting a 2. And 4 out of how many? And it's being rolled 5 times. So out of the 5 times it's being rolled, we want 4 successes. We'll do this anytime not everybody's doing the same thing. So I definitely want 4 successes, but I also want 1 failure. A success is rolling a 2. So what P is the probability that on a single roll of a die, you get a 2. And so that's 1 out of 6 options on that die. So this represents, the 1/6 represents the probability that 2 comes up on any given roll. Okay. And I need that to happen 4 times. I also need a non-2 to come up, which has a 5/6 probability because there's 5 non-2s on there. And I need that to happen once. So this is just an application of the formula, right? So out of the 5 rolls, and I'll highlight here, out of the 5 rolls, I want 4 to be the same way. I want those 4 to be a 2. And so the probability of getting a 2 is 1/6 and then 5/6. So the first thing that we're going to do is run the C54. And I know in my videos I show this, but let me switch over to the camera and I'll show you my calculator in case that is hard. So I'm going to just clear out what I've done already on my calculator. I'm sorry, it's not so great, but remember we wanted 5, and then I hit this PRB button right here, select the C, and select the 4, and hit enter, and it tells me it's 5. So that's how I run it on my calculator. Let me take that now over to here. So I have C of 5/4, which I just found out was 5, times 1/6 to the 4th, times 5/6 to the 1st. Now, I did run into a student that was wondering, hey, I'm doing all this right, Jensen. I'm doing it the way you're doing in the videos, but when I plug in the answer, it's marked wrong. When I looked at what she was answering, the question said to leave your answer in fractional form. So I'm going to do it both ways. The first way I'm going to do it is in decimal form. And I would literally just type in 5 times 1 divided by 6 to the 4th times, open parenthesis, 5 divided by 6 to the 1st. And so let me do that really quick. I got 5 times 1 divided by 6 to the 4th times, open parentheses, 5 divided by 6 to the 1st, right? Or just leave it alone. And so an acceptable answer would be 0.0032, just my decimal point there, 15021. Now, if they want it as a decimal, they're going to ask you to round it appropriately. So if they say to 3 decimal places, we'll say 0.003. If they say 4.0032. If they say 5.00322. We'll follow that to a T. Now, if you're looking at the directions and it says to leave as a fraction, that's exactly what we want to do, is just leave it as a fraction. So what I mean by that is, remember, all this right here was the work to get it as a decimal. So if they're asking me to leave it as a fraction, then I would write 5/1. I would then go to the 1/6 and take 1 to the 4th divided by 6 to the 4th. And then I would multiply that times 5/6, each one of these raised to the 1st. And so obviously I get 5/1, 1 to the 4th is 1. 6 to the 4th is, I don't know. So I put it in my calculator, and it comes out to be 1296. 5 to the 1st is 5, and 6 to the 1st is 6. Then we simply, to get our answer, multiply the tops to get 25. 5 times 1 is 5, times 5 is 25. And then I hit 1 times 1296 times 6. And I get a 7776. If it's asking for it as a fraction, the computer will only take the fractional response. So I wanted to show both. And I apologize that that wasn't in the first video. Next question. Hopefully that's okay. You can always back up and look at that. The next question is simply, hey, let's run the formula. Now, I just used the formula without describing it because it's described in the other videos. But remember, the formula says the probability of x successes is C of nx, little p to the x, times q to the n minus x, everything being multiplied. And so as I go here to solve this problem, they're giving me much of what I need. Probability of 2 successes is equal to C. They told me n was 19. They told me x was 2. They gave me p as 1/4, and I know that needs to happen twice. And then I need to think about what q is. If the probability of success is 1/4, meaning if there's 1 success out of 4 total, then there's 3 failures out of 4. So if there's 1 way to get it right and 4 ways to get it out of 4 total, then there's 3 ways to get it wrong. And so if I only want 2 of the 19 to be successes, then I want the other 17 to be fails. And so I'm just following that, right? N minus x, 19 minus 2. Q is always 1 minus p, right? Coming through there. Like if they give us p, we absolutely know q by just taking it away from 1. I'm not thinking that they would ask in this case for us to give the number as a fraction because it's going to be a very big fraction. But let's go see what C of 19.2 is. Again, I'm going to switch to the camera and bring my calculator in here. And remember, we want to do 19. So you can barely see the 19 up there. Hit the PRB button, C, select that guy. And then I'll type in the 2. And then when I hit equals, it will be not as big as I thought, 171. Okay, so we just remember that 171, and we come here to our work, and we are like, okay, that's 171 times 1/4 squared times 3/4 to the 17th. Okay, 171. Let's keep it as a fraction this time. I know they said that they probably wouldn't, but what if they did? Well, we just leave 171 as a fraction. We square both of these. 1 squared is 1. 4 squared is 16. Now 3 to the 17th, this is why I don't think they're going to do it. 3 to the 17th is going to be huge. Yeah, it's this huge number, 129140163. I really doubt that they would do that. 4 to the 17th would be even higher. Yeah, they have to put it in scientific notation. So I'm pretty sure in a problem like this, they wouldn't ask for it to be in a fraction because it is just so big because you have 19 selections. The other one was relatively small. So this time we're just going to plug it in as 171 times open parenthesis 1 divided by 4 to the second times open parentheses 3 divided by 4 to the 17th. And so we take our 171 times 1 divided by 4 squared times 3 divided by 4 to the 17th. And we hit equals, and we get a nice decimal number, 0.080337369. Now they'll ask us to round somewhere, and we want to make sure we round appropriately, or the the computer will mark it wrong. The last example that was asked for is this number 12. And so number 12 is down here. Beth is taking an 8-question multiple choice exam where each question has 3 answer choices, only one of which is correct. Beth decides on answers by rolling a fair die and marking the first answer if it shows a 1 or a 2, the second if it shows a 3 and a 4, and the third if the die shows a 5 and a 6. Find the probability that she gets 4 correct answers. So we're trying to find the probability that Beth gets 4 correct answers. So the first question we need to ask ourselves is, how many questions is she answering? 8. Says it right there in the problem. There's 8 questions, 4 of which need to be correct. Now we need to know the probability of getting something correct. Well, there's only 3 answer choices, 1 of which is correct, and she has a balanced way to choose the 3, each one having an equally likely chance of happening. And so there is one of those answers is right out of 3 total, and I need that to happen 4 times. 2 of those answers are wrong out of 3 times, and I need that to happen also 4 times. Okay. C of 8, 4. Again, on my calculator, if you can rewind the video, I'm just going to type in 8, the PRB button, get the C and the 4 and hit enter, and it's going to tell me 70. 1/3 to the 4th times 2/3 to the 4th. I will look at the answer box and say, what does it want me to do? And if it says a decimal, I'm going to type 70 times 1 divided by 3 raised to the 4th times 2 divided by 3, remembering the parentheses, raised to the 4th. Again, this second 4 is because if you have 4 right out of 8, then you have 4 wrong out of 8. So then we just run this in our calculator. 70 times, open parentheses, 1 divided by 3 to the 4th times, open parentheses, 2 divided by 3 to the 4th. And the answer comes out to be, in decimal form, 0.170705685. And again, I'd round wherever they told me. If I look at it, so right, this is decimal. If I look at it and it says, hey, do it as a fraction, okay. 70 over 1 is how I'd write that as a fraction. Times 1 to the 4th is 1. 3 to the 4th is 81. 2 to the 4th is 16. 3 to the 4th is 81. Let me just check that I'm remembering those right. Yeah, 3 to the 4th is 81. 2 to the 4th is 16. So what do I do to finish the problem how they want it? I ask myself, well, what's 70 times 16? And it works out to be 1120. What's 81 times 81? That works out to be 6561. If they ask for a fraction, that's what they want. Now notice if you take the 1120 and you divide it by 6561, you get the exact same decimal. So it's really just giving it in the form that they're asking for. So hopefully this video helps not only the student to ask, but all of you.